I don't think that's gonna happen this 9 weeks. You're gonna have to do it through testing. Lovely. This 9 weeks, your grade will be whatever your tests are. I will not put any more of these make-believe participation grades. I want you to reflect exactly what your knowledge shows. Super simple. And you can't complain because you didn't complain about the easy grades. So if you don't want to study, let it manifest itself. So let's begin. Now, whatever, you can be angry about it. I don't care. Does anybody have a problem? Oh, that sounds so good. Oh, you guys make me feel great. All right, so let's go. I don't know why my whiteboard's not opening up. Oh my gosh, really? Well, then you have an F. It's no big deal. Yeah. Why not? You've got an A's. Well, you lower your GPA, so don't fail tests. I feel like it. It's that simple. There we go. Now it's working.
Someone doesn't change their grade now. The fourth 9 weeks in.
Yes, this is the only 9 weeks that this is the end is what matters. In my opinion. Well, that does. So what you say? Everybody has authority. Are you saying there has to be an average of opinions that add up, and that's the truth?
I don't think somebody who just changes their opinion like this.
Why not?
Why do?
You can be corrected, can't you?
But you weren't wrong.
Oh, I was wrong. God told me so. All right. So here we go. I just did this real quick. So let's begin. Well, if you prepare, you should be fine. If you don't want to prepare, then you're gonna be.
I prepared for every test, and like, yeah, I passed some of them, but not all of them. And
That's
I end with a C.
That's fine.
What happens if I end with a C though? My mom's gonna
You'll be fine. You know what? Another student told me that last 9 weeks, and she came back yesterday. She's like, my mom didn't kill me. I'm like, I know you're alive. All right, so let's go ahead and take a look.
Or and you
Okay,
could
yeah.
ask my mom. She has a class field trip over there.
My mom might not kill me, but if I don't get an A, I won't get into college, and then my life will go nowhere.
No, you're fine. You're fine. You're fine. All right, guys. Let's take a look at that questionnaire. Can you see it though?
Yes.
It's because it feels like it's a little far away. Let me see if I can zoom in a little bit. I think it's. Oh, I think I am. So I'm gonna be as careful as I can be. Now, do you have your tables? It's very important that you have your tables. It says here, the petrol consumption of a certain type of car has a normal distribution with a mean of 24 kilometers per liter and a standard deviation of 4.7 kilometers per liter. Find the probability that the petrol consumption of a randomly chosen car of this type is between 21.6 kilometers per liter and 28.7 kilometers per liter. Well, they give you they give you the standard deviation. Whatever they give you there, they didn't like normally you would have them write. Like, so if I were to write this, I wouldn't even write N and I would just go ahead and just write this. The petrol consumption of a car has normal distribution with a mean of 24 kilometers. Well, what's the mean gonna be? What's the mean gonna be? 24. Now, let me just make sure. I think this book is not using mu. I think it's using X bar. Let me just confirm. Let me confirm quickly. Be careful.
You're recording, right?
I am recording. Yes. So our conversation comes out on the recording.
How much the conversation?
They use mu. Everything, including like I can't get a C because my mom's gonna kill me. It's like, bro, your mom's not gonna kill you. Stop exaggerating. All right, so mu is 0.24. I don't know why I came out blue right there, but whatever. And we also have to, yes, be careful. Sigma is 4.7. All right. Find the probability. And by the way, what's the distribution shape? It's normal, right? It's normal. So before I continue, can I draw this situation out? Can I do this? And can I do this? And can I do this? And then it says, find the probability that the petrol consumption of a randomly chosen car of this type is between 21 kilometers and 28.7 kilometers. Wouldn't 28.7 be somewhere over here? Just from a standpoint of just, and remember, these are kilometers. Just to make it like, you know, just more or less, it's not to scale. It's not taking into consideration. This is just a depiction, a visual depiction of the situation. Now, how many z-scores am I supposed to do? Do you remember what a z-score is? Okay, so how many z-scores am I supposed to do then? 2 of them, yes, correct. So we have a z-score. Z-score is x minus mu divided by sigma. So that's going to be, well, one of them is going to be 28.7 minus 24 divided by 4.7. And the other one, this is a z. The other one's going to be 21.6 minus 24 divided by 4.7. So let's go ahead and execute both these calculations. 28.7 minus 24 divided by 4.7. So this is a nice number. This is 1 and 21.6.
Are you ready?
I did right, but maybe it's just taking a little bit longer for it to update than normal. You hear that bird? That bird doesn't need money. It does. What is it doing? It's making noise, right? What is it trying to do with that noise? Really? It doesn't have any purpose? Is he communicating? That's pushing it hard, but maybe it is. I don't know. Are you a bird watcher or something? I don't know. I don't know. I'm just, well, I think I am. From your test scores, it doesn't seem like I am. But it might be my fault. And it could be just my fault. It's not your fault. Don't know how to communicate. All right, guys. So this situation here is depicted by a standard normal distribution with a z-score of 1 and a negative 0.51 z-score. So we need to find this area. How do we find that area in between? How do we find that area in between? We got to use our tables, right? So you need to find the area to the left of 1 and to the left of negative 0.51, right? So if you have your tables out, you should go to your table. I think I have a table here. And I'm going to go to 1.00. So this one will be 1.000 if you like. That's going to be 0.8413. And then we have negative 0.51. Do we have such a z-score table that gives us negative z-scores, or we just have the positive? Yes, correct. So Natalia said in order to find negative 0.51, we look up whatever 0.51 says, positive 0.51. And so we say that the phi of 1.0 was 0.8413. The phi of 0.51 is equal to 0.6950. The phi means the area to the left. Therefore, the phi of negative 0.51 is just 1 minus the phi of 0.51. So that's going to be 1 minus 0.6950. And so 1 minus 0.6950, that's 0.305. 0.305. And so now you have this area here, which I wrote over here, and this area here is going to be indicated here. And so we're going to subtract those two areas. The area between will be the difference between 0.8413 minus, and that's supposed to be a 3, not a 1, 13 minus 0.3050. And so 0.84 minus 0.3050, and that's 0.5363. 0.5363. And so we can state now that the probability of X being between 28.7 but greater than 21.6 is equal to 0.5363.
What does it say? Oh, never mind.
And that's it. That's how you do this question. That's worth 4 points. That is a super easy question, which I would love to test you on next class.
You're telling me stats, the full test, basically.
No
Or like
stat,
most of
well,
it, they choose about, but this like,
yes.
this is like the hardest it gets.
so no, well, I think this is the easy part. The hard part of the stats test is the probability in accounting. And they're gonna have a question on probability in counting. Well, some people don't find it hard. I would have found it hard. Even as a teacher, I think about the questions thoroughly before I begin to answer them. I don't just assume quickly. I read them through. I'm like, okay, this is what they want. Because they just feel foreign to some of us. So you have to practice. But again, let's try our best. Well, pure math, you've been brought up with algebra, and you've done algebra twice or something like that, and it feels different. But stats definitely from a mathematical standpoint, it's easier. Like the math you're doing here is just super simple.
It's harder because we never done it.
Because there you go. It's just harder because you haven't done it before. This is your first exposure.
I have a question.
Yes.
You know how the work period is going to be more tests?
Huh?
You said that this work period is going to be more tests next week.
Don't stress over it, Mama. I'm not gonna murder your grades. Don't worry about it.
The old tests and reviewing, so I can see what we're doing before.
Yeah, that's fine. No worries. Yeah, they're over there in the stack. Don't worry. Don't stress. They're all on teams. Everything's on teams. Right? I practically reviewed every single test. Don't stress over these things.
No, I know, but like to have like my papers do what I need to do.
Okay.
Because I need to pass both of these tests like to get the college credits.
Now look at their grading scheme, how they did this. This is the work they would want you to do. Now it looks very like, they got their 0.537. We got 0.5363. Did I write down the correct value for the other one? 0.69. So did I write 0.51 correctly, or did they get a different? I see.
No, you put 6950.
So did I maybe the point, but here I'm looking 0.51, 0.6950.
Well, technically it was point, wait, it was 0.51, it was 0.51.
Oh, there was more decimal places? There were more point. Okay, so
But if you run,
no, this is the,
it would be 0.51.
no, you're right. No, they're right. They're right. So let's correct it because they have more decimal places that we can do. This is important. They want to see you use the extra decimal places. So when I got this value here, I just round to 2 decimal places. No, we're not allowed to do that. We got to round to 3 decimal places. So let's correct that on our notes. So we have good notes. So in theory, I was supposed to write here negative 0.511. This should have been an extra 1 here. And now all of a sudden, this guy here is not 0.6950. When I come here to my table, I would have to have 0.0003 to it. So in reality, the phi of 0.511 is 0.6950 plus 0.0003. So in essence, we're going to do, and I should just change this here already. So the phi of negative 0.511 must equal 1 minus And I should just rewrite this, but whatever, I'm too lazy. So this is super duper important because they want 3 decimal places. Now, regularly, like in honor stats, we always do 2 decimal places, but when they give you the extra decimal place, then you need to take it seriously. I mean, they're still gonna give you points if you forget, but there's no reason to forget. Okay, there's no reason to forget. So there we go, and then all it changes is 0.8413 minus 0.3047. So let me just change this to 47 right here. And then this becomes 5366, 5366, and this here is. None of your teachers have bought the Surface? Not yet. Have you guys talked to them about it? You're right. But you guys are taking reading at this point? Okay, I see. How about, I think chemistry would benefit from this class or physics.
No, I'll take chemistry.
All right, so they give you 4 points for this, and now I went, obviously I'm drawing all these things out, but essentially that's what you're doing. You're taking the phi of one minus the other. That's all you're doing there.
Wait, I have a question.
Yes.
Do you, to get the answer, do you have to write like the P?
No.
21? No, you can just write like the number and you're fine.
Make sure that if you don't write the P, that you write it in words.
Okay.
If you're not sure, then write it with words. Write it with
Wait,
words.
so the answer is
The answer is this. They would have accepted that.
okay.
And they would have also accepted, but they probably would have taken a point off, maybe, if that much, for doing it to 2 decimal places. You're still showing ample understanding of how to get the area. I mean, again, I'm not a grader and,
So would you recommend us writing it to the 4 decimal places, or would you rather?
okay, so for this answer is 4 decimal places.
Okay.
But for the z-scores, I would be doing 3 decimal places for sure, Okay. All right, so are we good with this? Is that a question that seems like it's too difficult to do? No. Now, the next question is a little bit more difficult. So let's make sure we're on point with it. Let me go ahead and do something with my magic thing here, and we'll do that second question. And then I'll leave the questions there, and I'll try to pick out 3 that you can do on your own to practice at home. Okay. And hopefully be ready for me to ask you some questions next class on this. Yes. And I don't know why it doesn't accept my things. There. Me hacen cógelo. Incredible. Really? I don't know what to do now. There, I did it. It just took forever for it to do. It took forever. All right. So there, that's all I wanted to do. I wanted to slide. Now let's go to look at question number 2. Do you guys work out today?
No.
You didn't work out today?
Well, it is only 9:26 in the morning.
Are you telling me you couldn't wake up early enough to get a workout in?
I
No.
really wake up early enough for school. I
Oh
was
my
supposed to wake up early and get stuff.
You guys are stronger than this.
I already came late today. There we go.
All right, so let's take a look at number 2. Okay, so lengths of a certain type of white radish are normally distributed. So what do we know about the distribution, the shape of the distribution? It's normally distributed with a mean of mu centimeters and standard deviation of sigma centimeters. 4% of these radishes are longer than 12 centimeters, and 32% are longer than 9 centimeters. Find mu. So here's what I'm gonna do first. Let's draw this here. Do we know mu? Do we know mu? No. Do we know sigma? Do we know sigma? No. Now, these are x's. This is your random variable x, which has to do with the length of a white radish. Now, it gives me 4% of the radishes are longer than 12 centimeters. So could I put 12 centimeters here and shade this region here, and that would represent 4%? Would that make sense? Would that area constitute something of good representation of 4% of the area? Or is that more than 50%? Yeah, it's way too much. Obviously, you would not put that in the middle here because it'd be dumb to do this. This is 50% of the area. So if you were to put 12 somewhere, wouldn't it be like around here? Let's say, and this is 12, and this area here represents a mere 0.04, which is the decimal representation of 4%. Would you agree? And now the next part says, and 32% are longer than 9 centimeters. So for the sake of it not being cluttered up, let's just pretend this is the same distribution. Here we have our unknown mean. They're the same distributions, by the way. Both of them are the same. They're the same distribution. Okay. So 9 would be a little bit less than 12, but we wouldn't put it in the middle because it says here longer. So 32% are longer. Would something like this be better? Like here's 9. These are X's, by the way. And this comes out to 0.3200. Would that be fair? Does that make sense? Now, what you got to see here is we're going to have z-scores associated with each of these. In other words, if this is 0.3200 to the right, what is it going to be to the left? What area would it be to the left? It would be what? 0.6800. Agreed?
Wait, how'd you get that?
Well, what's the whole area of the curve? 1. What's 1 minus 0.3200? Okay. And then over here,
Is it always 1?
yes, all density curves have an area of 1. And so here, this is what going to be 0.9600. So what I got to do is I got to find the area to the left and associate it with an appropriate z-score. Does that make sense? This is an area to the left. We found both areas to the left. Obviously, we were quoted areas to the right. All right. So let's go ahead and do that. So we got 0.966. We got something on the table here that says for a z-score of 1.75, it gives me a probability, an area of 0.9599, not quite 9600, but if I add 0.001 to it, I would have 0.9600, right? And that would represent a z-score of 1.751.
How'd you get 1.75?
Well, look. Do you have your table out?
Yeah.
All right. So now try applying an area in the middle, not on the edges, an area to the left of 0.9600. Do you realize it doesn't exist? But there's 0.9599. You see that? Here, let me show you. So in this case, they quoted an area we got. So if you come here to 0.9599, but that's not 0.96.
Oh, so you're gonna look for this.
Well, yes, that corresponds to 1.75.
Okay, so you're looking for the closest.
Yes, but here's the thing, if you add 0.0001, it becomes 0.9600, and that's 1.751.
Okay, and that would be the Z for the first one.
Yes. And now similarly, so we just found this Z is this guy, 1.751. And now we got to find the other Z. So we're going to find 0.6800. 0.6800. So let's see. We got for Z score, of 0.46, we have an area of 0.6772. But we need 0.6800, so we got to add 0.008. Now, I don't have anything that exactly gets there, but I have, if I add 0.02 to it, so in this case, the previous case, we had a 0.001, but if I add 0.002 to it, right? We're gonna add 0.0007 to this. So for z-score of 0.462, we have 0.6779, which is really darn close. And so we can say that this z-score here is 0.462. So now we found both z-scores that we need. And why do we want these z-scores? Well, simply said, we're trying to find the mean and the standard deviation. So here we have a z-score equals x minus mu over sigma. Let's say we rearrange this. Z sigma equals x minus mu. And then we can either write x equals mu plus z sigma, or we can write mu equals x minus z sigma. Either one works. I would rather use this one because we're trying to find mu or sigma. I mean, we could rearrange it to represent sigma, but let's make it easy on ourselves, because you could rearrange it to do this. You could say from here, I don't know, if you want to, you could say that sigma equals x minus mu divided by z, but that seems difficult and cumbersome. So on one hand, let's scroll this up a little bit. We have that mu equals, well, the x for the first one was 12 minus 1.751 sigma. For the other one, it would be mu equals 9 minus 0.462 sigma. And guess what? Both of them are the same distributions. So they have to have the same mu's. So if both of them, if the mu for each one of them are the same, then we could just say 12 minus 7.51 sigma must equal 9 minus 0.462 sigma. And then we can solve for mu. Obviously, I would add the 7.5 to the other side. It's easier. So you have 12 equals to 9, 7.5, 1.7. Look at this. I miswrote this real bad. It's 1.751. So I'm still going to add that way. So 1.751 plus a negative 0.4620, and that comes out to 1.289 sigma. And so now you can solve that. You subtract the 9, you subtract the 9, you get 3 equals 1.289 sigma, and then you divide. 3 divided by 1.289, that says that sigma equals 2.32. I'm gonna go ahead and write what the calculator gives me, and then we'll talk about rounding. Okay, so we found sigma, and so now we can take any of that answer. You should keep it in your calculator in its memory, and you just substitute it back into here or here, and that will give you mu, right? So we have mu equals 12 minus 1.751 times 2.37 2.32739. I've kept it in memory in my calculator because I don't want to, because actually it's a much longer number. But I've kept it in memory in a calculator. And so I take that, multiply by 1.751, 12 minus that answer I just got. And it says that mu is equal, huh?
Which formula?
Well, I'm going back to the original ones. I'm putting sigma into the original ones.
Oh, okay.
And it doesn't matter which one I pick, I should get the same answer. If you're really paranoid about that, then I mean, you don't have to, you could just try it on both and make sure you're getting the same answer on both if you're really paranoid. And so what we have is we have the following. We have, you look at the original question and you see they asked you to keep certain, how many decimal places. I'm gonna go ahead and go with 3 decimal places. So I would say mu, I mean, if you're measuring this, honestly, if I measure radishes, I'll keep it to 1 decimal place, honestly. And maybe do a standard deviation to 2. But we'll take a look at their answer key. So I'm taking this test right now. I would answer the mean is 7.9, and I would say sigma is 2.33. Because you know, if you're gonna measure a radish, if you're gonna measure really to like 3 decimal places, doesn't make sense. They didn't indicate to you that they wanted 3 decimal places or anything like that. So you just, I mean, your work shows your understanding. Assuming I got the work right, I want to take a look at review the answer key. So you see that the mark scheme, what they're looking for. Now, obviously, I'm explaining this to you. You can't be doing this on the test like I'm doing. You know, I mean, you could draw both shapes, but it's better that you know how to proceed quickly. Okay, so let's take a look at the mark scheme. So okay, so they went 2 decimal places on both of them. They answered 2.34 on that, which would be they're taking less decimal places than I am, but it's the fine answer. Okay, what do they want? Rounding to plus or minus 1.75 seen. Okay, 0.468 seen, and in our case here is 0.468 seen. They put 0.468. I put 0.462. Why did I do that? No, I'm getting 0.462. I'm gonna keep to that. There's a mistake on their part. 0.468 has 0.0029. That's a mistake on their part. No way. An equation with a z value, there you go. And like you have this part, they're not even showing it, but that they mean that you're doing that system that I just did. Like, you know, and you're using, in this case, we use substitution as the main method, not elimination. Which in many ways is a form of elimination when you think about it. Okay, questions or concerns? Did that seem too hard? That's the hardest one. That's the hardest one. Questions or concerns? All right, let's go to 3. Okay, wait, I zoomed in too much. Let me zoom out. All right, so here we go. Okay, so this one is actually has nothing to do with normal distributions. It has to do with binomial distributions. Okay. But it's worth 5 points. So the last question was worth 5 points by itself. This question is also worth 5 points. And the first question was worth 4 points. Those are a lot of points you can accumulate. So it says there's, say, 3 conditions that must be satisfied to be modeled by binomial distributions. Do you remember those 3 conditions? Okay, what's the first condition? Condition number 1. Correct. So there must be 2 possible results only. 2 results. Success or failure. What's the second one? Fixed number of trials, yes. And what's the last one? Probabilities have to remain what? Constant. Probabilities are constant. What, yes, essentially it's if with replacement is one of the keywords we use. It depends how we want to apply it to binomial, but essentially those are it. Probabilities are constant. Fixed number of trials. So probabilities don't change from trials to trials. Okay. And we have two possible results, success or failure. Now, so that answers part 3I, and that's 2 points. So how about double I? It says there, find a probability. Well, George wants to invest some of his monthly salary. He invests a certain amount of this every month for 18 months. Okay. So how many? Okay. For each month, there's a probability of 25% that he will buy shares in a large company. There's a probability of 0.15 that he will buy shares in a small company. And there's a probability of 0.60 that he will invest in a savings account. 0.60 plus 0.15 is 0.80, 0.75, and 0.75 plus 0.25 is 1. So we're good. All probabilities are accounted for. Find the probability that George will buy shares in a small company in at least 3 of those months. So the probability that he will invest in a small company where X indicates, the brand of variable X indicates he's investing in a small company, is at least 3. Okay. So if it's at least 3, and what's N going to be here? What's N? How many months he's invested? 18. What's the probability that he will invest in a small company? 0.15%. Therefore, could you please tell me what is the probability that he would not invest in a small company? You see that? We sometimes call this Q. This is the failure, our failure. There's an 85% chance that he will not invest in a small company. Now, the probability of X being greater than or equal to 3 would be the probability of 3 plus a probability of 4 plus a probability of 5, all the way to what? All the way to what? All the way to 18. So potentially you'll be doing 16 different calculations, right? Or you would realize that 1 minus the probability of 0 plus a probability of 1 plus a probability of 2. If you just did 0, 1, and 2 and added them together and take 1 minus that, you will get the same result as if you added 3, 4, 5 all the way. This is the notion of complements, right? Remember that the probability of an event plus the probability of its complement must equal to 1. That's what we're taking advantage of. And that's what they want to see you do, because if not, you're going to waste a ton of time calculating 18 minus 3 is 15 plus 1, 16 different calculations, a lot of calculations for what? So what do is you got to remember your formula. You don't have to remember because it is on your sheet, which I'm going to give to you next class. So I'm going to give to you the reference sheet you're going to have, because you don't have to memorize everything. But let's assume you grow up to be a stats teacher. The probability of X equals to what? NCX P to the X 1 minus P, which is Q, to the N minus X. Right? And so you're going to go ahead and calculate that. So you're going to have 3 calculations. You have probability of 0, which is 18C0, 0.15 to the 0, 0.85 to the 18, plus P's of 1, which equals to, well, I won't put plus, I'll just separate them. 18C1, 0.15 to the first, 0.85 to the 17. And then you have also a probability of 2, which is 18C2, 0.15 to the second, 0.85 to the 16. And you're gonna, I should have written this nicely, but of course I didn't. I'll write the answers down there and then we'll just subtract them and you should get an answer. So the probability of 0 is going to give you some sort of decimal. Probability of 1 is going to give you some sort of decimal, and probability of 2 is going to give you some sort of decimal, of course, between 0 and 1 inclusive. So 18C1 is 1, 0.15 to 0 is 1. So really all you calculate is 0.85 raised to the 18th. Keep it in memory in your calculator. I'm going to go ahead and just, for sake here, just write it to what the calculator gives me. So my calculator rounds to here. The other one is 18C1. What's 18C1? What's that going to be? Okay, so we know that 18C0 is 1. So it's 18.
Yeah.
So the next one's always 18. Whatever the n is, 8, you know, if it's 5C1, that's 5. All right, so we have 18 times the 0.15 to the first times 0.85. What is a U fair end, guys?
I don't know. And were they in the April? I think so.
I think it's this week.
April 10th. Oh, I read out one.
April 10th. So we got some time to go. 18C2. Now, do you know how to do 18C2? You should do it with your calculator. I mean, if not, look, 18C2, remember it's n factorial divided by n minus r factorial times r factorial. And so that's going to be 18 factorial divided by 18 minus 2 factorial times 2 factorial, which is 18 factorial divided by 16 factorial times 2 factorial. So that comes out to be 18 times 17 divided by 2 times 1. But, you know, so 18 times 17 and divided by 2, that's going to come out to 153. And so the next calculation, take 153 times 0.15 to the second times 0.85 to the 17. And that's it. Sorry, 16. Almost messed up. So that's 0.255609. Now I've kept all these numbers in the calculator. So now I just say, all right, let me drag this a little bit to the side because you guys are not seeing all that. Let me zoom out a little bit. Okay, so now I'm getting that the probability at x is greater than or equal to 3 must equal to 1 minus the sum of those numbers, right? So 0.25 something plus 0.17 something plus point something. And so you have 0.479662. I kept that in memory marker. 1 minus this, and that should equal to, so the probability of x greater than or equal to 3 must equal to 0.5203. I'm gonna report to 4 decimal places at the end. I'll wait because some of you are writing. All right, and that's it. These 3 questions are typical questions that you'll see on the stats test that are if you take this preparation we're doing today seriously and before we take the test, because we're going to have more time to prepare for stats because we take pure math first, you should be able to nail it. Does that make sense? It's not that difficult. And so let me, before I'm ahead of myself, I can just review the mark scheme with you guys right now, but let me just demolish this right here and just end it so that I can put this on Teams. So I'm gonna stop the share. There's my mug and end meeting for